Well, hello everyone, and welcome back to Adrian's Digital Basement. Well, I was just playing on the cursed Famicom, and this thing, last time I worked on it, really broke me because I could not get this thing working. Strangely, after, well, I've been using it for about an hour now, this thing just works perfectly. No more glitches and no more issues. Now that kind of leads me into the question I have for the subject of today's video. What makes a Nintendo a Nintendo? Obviously, when we look at a game console like this NES, the plastic case is a big part of it. But when you talk about what's inside of this, the electronics, well, I say that there's a few components in here that really make this thing the console that it is. And it's very specifically the CPU, which contains the sound circuitry, and the picture processing unit or the graphics subsystem of the Nintendo. The rest of the electronics that are in the Nintendo are just off-the-shelf parts, and I really don't think they have much to do with what makes the Nintendo a Nintendo. Well, that leads me to the subject of this video. This board I'm holding in my hand is the Hello FC version 5.0. And what this is an entire replacement motherboard for the Nintendo Famicom, or the family computer. I ended up getting this because I thought my repair attempts on the Famicom were unsuccessful, and I thought that this board would be a good shortcut, or a cheat, so to speak, on how to get this console up and running again, and honestly to make it better than it ever was. So join me in today's video where I explore this Hello FC board and see if this is actually a good candidate to go inside my Famicom. So without further ado, let's get right to it. So I have to admit, I'm really shocked that this Famicom seems to be working properly. I have some notes here after the repair, and I wrote, glitches and crashes after 15 minutes, and I thought maybe it was the voltage regulator or perhaps the clock that was messing up. But if you watched my last video on this thing, you saw that after this thing sat for a while, it started completely going crazy and glitching out, and the game that it would be running, which I think in the case of my last video was Galaxia, and this exact cartridge would crash and just act totally weird and random. To prepare for today's video, I fed 9 volts into this thing and just let it sit on the bench running the game demos for hours and hours, and there was no glitches and no issues. So this thing does appear to be working properly right now, but frankly, I don't fully trust it. And if you do any repair work yourself or you watch my videos regularly, you're going to know that these intermittent faults are some of the hardest to troubleshoot. Because right now, the console is not misbehaving. How am I even supposed to try to figure out what exactly is wrong with it? After the last video where I was completely defeated on fixing this console, I started really kind of mulling it over in my head, trying to think about the avenues I would take to try to repair it. But while I was doing that, I was also browsing AliExpress, as kind of one does. And I came across something that was kind of interesting. I looked on there to see if there was an AV mod module for this original Famicom for a good price. In the video on this console, I ended up doing an AV mod to this, just my homebrew style mod, and while it works, with this being the audio output and the RF jack being the video output jack, well, it's not great. The video is kind of noisy and jumpy, but the audio is really buzzy and just doesn't work that well. One of the other issues with these machines is that they have a lot of jail bars in the video. Even if you put a proper AV module in this, an aftermarket one that is, you still end up with a lot of jail bars just due to the way the PCB is designed. The traces for the video signal just run right next to data signals, and of course you get some coupling, and that introduces a whole bunch of noise in the picture. As far as the audio noise, it looks like the original RF modulator that's on this actually has a bunch of high-pass filtering, so it filters out some of the low-level buzzes that you would have on the audio circuitry, and it probably has an effect on the overall audio quality. But to be honest, it's better not to have a bunch of buzz and hiss and stuff that's in the video on this, which is also very susceptible to whatever's on screen bleeding over into the audio. So while surfing around on AliExpress looking for potentially a new replacement PCB for the AV output on this to give me cleaner audio and video, well, I came across this board. And as I mentioned in the intro, the Hello FC LV 5.0, it's an entire replacement motherboard for the Famicom, and this thing is only 40 bucks. Now, as I mentioned in the intro, the hearts of the NES, the CPU and the PPU are not contained on this board. Those are the expensive parts, and I'll need to transplant these 2 chips onto this board from the original motherboard, really to make this 100% fully compatible NES. Well, you might notice on the board right away, this whole section of the board contains a much more modern and up-to-date power supply. This is a DC to DC converter that does not use a linear regulator, which means you could input something like 12 volts into this thing, and it's not going to get overly hot, generating the voltage rails that the motherboard needs. In addition, they did away with the RF modulator, and they included an AV mod right on the board, and we have to hope at least that the design of this audio-video section is a lot better than the simple mod that I did when I did the AV mod on the actual Famicom. That will result in much cleaner audio and much cleaner video. Not to mention, of course, the entire PCB has been relaid out, so we have to hope that those video traces are guarded and not just exposed to a bunch of data signals, although the black PCB makes it kind of hard to make that out. I have a feeling there's going to be people watching who think that maybe using a board like this is cheating, but let's be honest, this was $40 shipped, and that is such a cheap price that with a little bit of work transplanting some parts and chips from the original console onto this, potentially are going to make this Famicom a much better and more reliable console than it ever was, at least with the flaky motherboard that's in here and the noisy audio and noisy video. And the irony is, I did find a few AV mods floating around on the internet, which is just the little AV board that goes into the back of the console that has the power supply and the audio video section on it. And that was almost $40 shipped. So I thought, let's try out this whole board for $40, which came exactly like you see it here, which should give this Famicom a nice solid upgrade. All right, first things first, let's take apart this Famicom. All right, there we have it. There is the inside of this Famicom again. Now on the AV board, there are a couple mods. This is the audio output that goes out the back of the case that carries the audio. We have a capacitor that I have installed. This is now the video output. I did end up removing a whole bunch of components from this board just to cleanly route the video signal to this and not have the whole RF circuitry working anymore. Down on the main board, I installed a couple capacitors between the ground and the 5-volt rails. And this helped quite a bit when it came to cleaning up the video signal, aka reducing the jail bars. Now you'll notice right off the bat that these two boards are a little bit different, aka this has a separate PCB for the AV section, but in this design, it's built onto the board. I don't know if there's another case that this fits into where these are exposed on the back. I assume maybe an aftermarket case, but clearly the original Famicom board, it does not work. Luckily, when I picked up the board, this came with it, which was just a small little PCB that's designed to mount in the back. And I think the intent is I'm going to relocate these connectors off this board, move them onto this, and then we're going to use a little cable that goes from there to there. This is obviously going to be installed like that, and then that'll allow us to maintain these back ports. Besides the CPU and the PPU, which I'm going to have to desolder and move over to this board, well, there are some other components we're going to have to do that with as well. One is this 15-pin expansion connector. This is used for external peripherals, and I think it's something that's just not made anymore, so it's not even installed onto this board. In addition, the pin headers for the original controllers are also not installed on this. It only has a couple standard 2.54mm headers installed, which are not the correct pin pitch for these, so I'm going to have to desolder those two connectors as well. With the main board removed out of the original Famicom, the other difference we're going to have to take into account is this has a toggle on-off power switch, while the original Famicom has a toggle switch that actually makes its way over to the power board. Now it appears they tried to accommodate this difference with a connector that I assume is for the power input. The other thing I noticed though is there are two pins right next to the power switch that they have installed. I'm going to need to remove this from the board and probably connect this power switch to the two pins there. Probably be the easiest thing to do. Another thing I'm noticing is the reset switch. This is the reset switch. Clearly the switch that's on here is not going to be compatible with what's on the Famicom. Luckily, it does appear that there's a footprint for this larger switch that I can install onto this board. So what this is telling you right off the bat is this is not for the faint of heart. There are a bunch of things I'm going to have to move over besides taking off these two 40-pin dips, which means if you don't have good desoldering skills, I would not recommend a solution like this. And that's where probably just a simple AV mod would be a better solution, because all you have to do is remove this board and this ribbon cable and connect the new AV mod to the original motherboard. All the idiosyncrasies like the noisy audio and video are still going to be there on this board, even with the replacement module, even though it probably can do some more filtering than the simple circuitry that I added. But I'm just hoping that this replacement motherboard does a better job, at least for those quality issues. And of course, we won't have any issues with the unreliability that this board seems to have. Something on here, at least. If you have questions about how I did the AV mod on this, I will link back to the original cursed video where I do show the way I did it. And it's pretty simple and it doesn't require desoldering on the main board. All the modifications, if I recall correctly, were done on this upper board. There was no removing of transistors and stuff on this, even though that is the way a lot of people take to do the AV mod, like take the transistor out and do some stuff. I didn't bother with any of that. All the mods were up here. So it was pretty easy to do. and it should result in working audio and video. It's just if you can put up with the noise. So I'm going to get started with my removal of the parts off the original system. Just to recap, I'm going to take off the PPU and the CPU, the reset switch, the 15-pin expansion connector, and the 2 gamepad ports. And I'm going to be using my Hakko 301 to do all this desoldering work. It's an expensive piece of kit, so if you're going to do a lot of this work, I recommend something like this, or better even. But again, I recommend that if you don't have something good to desolder things with, like a Hakko or something similar, I really recommend not trying to do this upgrade. It's voiceover time. First thing I need to do is remove the 2 wires that go to the power switch on the original console. Now we're over on the new board. First thing to do is remove the power switch, since I know I'm going to be using the power switch that's built into the console connected to those wires I just disconnected. Next up, I'm working on the reset switch. The reset switch from the original Famicom looks like a key switch from a keyboard, and that's going to move on to this board. It has the correct footprint. I mentioned we're going to have to remove the connectors from the old Famicom board that go to the gamepads and move them onto the new one. But the new board has these pin headers, and I need to remove those first just to make clearance for the connectors I'm going to move over from the original board. And I will mention that anytime you're removing 2.54mm pin headers from boards, it can be difficult. The through holes they're connected to are tight fit. That means it can be really hard to clean out the solder, and the hot air helps, but I still struggled to get the pins out, and I had to really work on them one by one. You saw me using a hemostat, and I have to say that's an invaluable tool because you can grip things with it and it doesn't let go. So you can use your hands to pull stuff away from the board without having to squeeze as well, say with needle nose pliers. I will point out that if you look on a site like AliExpress, there are some really cheap and crappy ones. They do sell good quality ones as well, but make sure you opt for medical grade hemostats because the non-medical grade ones are pretty much useless. Now I'm turning my attention to the power and AV connectors. We know we're going to have to move all of these to that little PCB that's external to the main motherboard. Unfortunately, I don't have any replacements for the RCA jacks or the 2.1mm power jack, so I have to move them. Ideally, you have a spare set of these. You could just put those on the small PCB and leave these in place, because removing these types of connectors from these boards is very difficult. A bunch of the connections from all of these jacks are on the ground plane, and on this board, the ground plane is pretty heavy duty and all connected together top to bottom for shielding purposes. And to make matters worse, the connectors actually have these crimped or bent style pins on them, so they kind of clip onto the board. That means the pins on the connectors are not free floating in the middle of the through hole, and it just makes the desoldering process that much harder. Now, what's not evident here is how much of a struggle I went through to get these connectors off, and I ended up resorting to low melt solder, which you just saw me using a moment ago. That was really the only way to get these connectors off, so I highly recommend that you go that route if you're trying to do the same thing I was doing here. Now we're turning our attention to the old original board, and it's time to remove components. I'm starting with a 15-pin connector, and I'm realizing here that the pins are too thick for my desoldering iron, and I can't use it. So I got frustrated with that connector, decided to move on to the 40-pin dips, the PPU and the CPU. What's funny is I've removed so many of these that this part of the process is the easiest for me of removing all the things from this board. The only thing I have to be concerned about is the PPU has one repaired pin, because that was the one that was missing when I first started working on the Famicom. So I just have to be careful when removing these pins not to desolder the pin that I have added as a repair. Turns out there were a couple other repaired pins on the dip. I think some more things broke off, but someone else soldered those on before I got to them. Next up, I'm focusing on the bespoke gamepad connectors. I'm sure if something went totally wrong, I could have just connected the gamepad wires directly into the motherboard or used some kind of other connector like DuPont connectors, but I'd rather just retain the original connector because the new board has the correct footprint for them. So I'm just being extra careful to remove the old ones, just don't want to damage them. Now I'm just removing the reset button. This thing appears to be a key switch from a keyboard, so it comes out very easily, just like any other keyboard key switch. Now I decided to go back to the 15-pin expansion connector. Yep, I decided to use the low melt solder again. I think there would be no other way to do this unless I had an appropriate nozzle for my desoldering iron, which I don't have, that could fit over the pins. I really don't generally like this low melt solder, just it's messy, gets all over the place, but I have to admit it worked very well for getting this connector off. We're getting close to the finish line. I'm just removing the PPU and the CPU. The CPU came out with 0 issues. The PPU I have to be a bit more careful of because of that extra pin that might come off. And I don't feel like trying to re-repair that since I know it's working right now. Luckily, it came out without an issue. And here's all the components I've removed from the original board. Everything came out without any damage. Awesome. And also, take a look under the PPU. What is all this? That must have been from whatever happened to the board before I got it. Next up, I decided to remove and try to reuse the little cable that goes between the main board and the RF modulator. I could transfer that to the new Famicom motherboard. Before inserting the PPU or CPU into the new board, it has those rolled or round pin sockets. I have to very carefully straighten out every single pin just to make sure I can get them in without breaking or bending any of the pins. This is one of the negatives of using these types of sockets, but I still prefer them when you're using chips that have been desoldered, only because the cheap sockets that we can buy that are dual wipe can often get damaged when you plug them in and then pull a chip out that doesn't have perfectly clean pins. What's interesting is, on first appearance, the layout of the motherboard seemed pretty similar, but actually it's substantially different. The chips are all rotated around 180 degrees. And the PPU and CPU are also swapped in their position, with the PPU being closer to the cartridge port. Now it's time to start reinstalling components onto the new motherboard. Now, one thing I'm concerned about here is that I haven't tested the new board, so I'm concerned that if I reattach all the components fully, that if something's wrong and I have to go back to the original board, I'm going to have to desolder everything again, which I'm not interested in doing. So what I decided to do with the connectors is install them on the board just to make sure they physically fit, and then just solder on 1 or 2 pins on each of them until I know that this motherboard works properly. Now I'm moving over to this ribbon cable, and I have to admit, it was extremely fiddly. The problem is that the original cable actually is braided as opposed to being solid core, and it just meant trying to get them inserted into the holes was so difficult because small little strands would come off, and it just wasn't cooperating at all. When I went to connect the ribbon cable to the little external board, it became impossible, and I ended up cutting off a fresh strip by using an X-Acto blade, but that didn't make it any better. It was impossible. The real issue was the holes on the PCBs are just too small for this type of work. It should have been larger, and then it would have been fine. So you can see here I decided to cut little pieces of wire. I'm abandoning that ribbon cable entirely. This doesn't really show how long I worked on this. I think I worked on this ribbon cable longer than I worked on any other part of this up until this point. So needless to say, I was a little bit frustrated, and I should have gone to just using wires from the very beginning. Now it's time to test fit this board just to make sure it all lines up, and yeah, it seems to line up perfectly. One thing I realized is I want to connect the power switch to the same original location where it was on the first board, and they put a little connector in place. So I'm going to actually remove that and just solder the wires directly onto the board, just like it was on the original Famicom. Well, I think I'm ready for testing. One interesting thing about this is this part here is a bridge rectifier, so I guess this can take AC input or it could take either polarity, which is a good thing because I just checked with the multimeter, and the DC barrel jack, when I moved from here to here, even though I have these wires just going straight through, it actually reversed the polarity. I'm wondering if that's because it knew if you were using this, you might be using the original Famicom adapter, which is center negative, and maybe they assumed if you're using this jack, which is a different case, I suppose, that you'd be using center positive. Either way, I don't think it should really matter because of the bridge rectifier that we have before the DC to DC converter. I didn't really mention this before, but it goes without saying that the case is going to need to be modified. See this round jack? That's going to accept, I think, the red one. But the other 2 jacks aren't going to work because they fit through the holes where these switches were installed from the old RF modulator. So I'm going to have to drill these out so that it all works. But I think for now, what we need to do is just make sure this thing works, because I certainly put a lot of work into it. And if it doesn't work, I'll be kind of annoyed. I have the bench power supply connected up just like I had it before on the Famicom. And I think I'm ready to go. I'm going to turn the power supply on at 700 milliamps. It's running at 300 or so milliamps, which is very similar to what we were at before, but we did not have a video signal. And I'm definitely set for composite. So let's just see if the power switch is working properly. Yeah, the power switch is working, and I guess it was on the on position. Okay, I hear audio as well. I heard a click, that is. Let's just, oh. Okay, well, clearly we have a working console. It's just Where's the video? Now, potentially our issue is this. This is the video output pin from the PPU. Well, that was the pin that I had to repair by dremeling the body of the chip. So I'm going to go under the socket. All right, well, we do have continuity there, but where's the video? What happened here? All right, what I'm going to do just for a sanity check, I'm going to unplug the video, and I'm going to plug it into the test pattern generator. Okay, we have working video, so I know it's not the RetroTink. And I definitely have it plugged into the right connector that's labeled video out. Well, you got to be freaking kidding me. Let's just check to see. Wait, there's an AC offset, but that's fine. Let's plug the cable back in, so this should add the termination back to it. Yeah, video signal. But where is our video? I literally see video on the oscilloscope, but why is the RetroTink not showing anything at all? Again, just as a sanity check, there's the test pattern generator, so that's working. Now, I suppose the one thing that's weird, there's a lot of DC offset there. I notice there's a power LED down there. That's kind of cool. It's almost like it's missing the blocking capacitor for the video output. So there's the video out, and that's the signal. It's going to the white wire that's all the way on the left side. You can see the trace there. It goes to this board, and it must be on the bottom side because we don't really see anything there. In fact, looking at this side of the board, it almost seems like the trace is routed internally because you can see that trace makes its way to there, but we don't really see anything going to the video signal there. Oh, never mind, there's the trace, just hard to see. I hate the black PCBs. Goes to these resistors, almost certainly a resistor divider. That Q1 is almost certainly a buffer that is buffering the video signal. Hooked up to C8, there's a via, that's the video signal, I'm assuming, coming in. Let's flip this over and look at the other side. I don't think so necessarily, because that's this trace, which goes to there, and it also seems to make its way up to what is labeled LED. So I have to assume this is kind of 5 volts, and it's connected to that component, whatever that is. Is this capacitor here. So they asked, almost certainly that's a 5-volt rail. So that's just supplying 5 volts to the video buffer circuit. That via, that must be the video that comes from the main chip. So I guess what's happening is RetroTink doesn't have a blocking capacitor, so the video signal's not being decoded at all, just because it's all up above like 2 volts. So I guess what I need to do is remove this wire, the video wire, and add a blocking capacitor just to remove that DC offset. All right, I have a capacitor just sort of bodged on there. It's kind of ugly, but don't really see any other place to put that. Okay, let's see if this thing works. You're kidding me, nothing. And let's see what we see. That's a perfectly fine video signal. What is going on with the RetroTink right now? I fully admit I am completely at a loss here. I'm going to try a different capture device. This is a clone RetroTink. Just gonna see what happens because I don't really know what else to try at this point. Okay, so there's the clone RetroTink. Let's turn on the Nintendo. No signal? Is the video signal coming out of the Nintendo so non-standard, like running at the wrong speed? Wait a second, wait a second. Is the crystal oscillator the wrong crystal? Is this running with a PAL crystal on here right now? Okay, so for normal NES operation, 21.47727 is what we need. Oh, yeah. You gotta be kidding me. That is the PAL crystal oscillator. Come freaking on. Oh, you know what? Look at this. This came with it. That is the crystal we need. You know, I guess this kind of makes sense, to be honest, because this was probably for the China market, and therefore you'd be using the PAL ICs. And, well, that's what happens. If you run the wrong crystal, you get a video signal that's so non-standard that the RetroTink doesn't know what to do with it. And you know what? I notice here it doesn't have the little extra adjustment oscillator, so I'm gonna move that over as well. All right, there we have it. The PAL crystal has been removed. I'm definitely keeping this though, since I don't think I have one of these floating around. If I ever want to try to make a PAL NES, that could be pretty handy. So the correct new crystal oscillator is in, plus the little adjustment potentiometer. Okay, there's the clone RetroTink. Let's turn on the Nintendo. This is normal. Oh, yes. Oh, yes. There it is. There it is. It freaking works. Wait, what? Oh, okay. I think we have a bad, just a bad connection in the cartridge connector. I think that's this particular Galaxian cartridge. Oh, wait, what's odd? This is the real Galaxian cartridge. why does it have the red logo, which is the logo you normally get when it's in the fast auto fire mode? Is it in auto fire mode, or the color's just all screwed up? No, we are not in auto fire mode. Uh-oh, what's going on exactly here? Does the reset button work? Yes, reset works fine. Okay, it's just glitching. And that doesn't make sense because the entire composite video signal is generated inside the PPU. There's nothing on the board that could affect the tint, for instance. Nothing at all. Just for grins, we're going to try the PowerJoy PJ008. Nope, the colors are messed up on here as well. The letters should be yellow. And if we run Galaxians, this is the fast version, and the logo, yeah, that doesn't look quite right. It also looks like it's doing a terrible job with deinterlacing. Yeah, at least we have fast fire. Is the sound working? Okay, now I'm not getting sound. Okay, sound is working on this jack, but the other jack did not appear to be working. So that's fine. What was going on with this one? When I push it in all the way, it suddenly stops working. Two problems here. So there's some kind of a physical problem with the audio output on the one jack, but that actually doesn't really bother me. It's a mono console. I don't need stereo audio out. But the bigger problem is what's going on with the colors. So I need to switch back to the RetroTink 5X Pro because this clone RetroTink may be our entire issue. Okay, we're back on the other RetroTink. I gotta reset this. Oh, okay, it's fine. Yeah, the color there looks completely normal. So I put back in the original cartridge. There we go. Blue logo, all looks normal. The output of this console looks very sharp, but you're seeing a lot of the dot crawl, which unfortunately is just a side effect of the composite video through the RetroTink. All right, so I have the game paused right now. Now the audio is connected, and if I unpause it, it's loud. But the good thing is there's no buzzing whatsoever. It is totally silent. Okay, next test on the PowerJoy, let's check out Goonies, because Goonies had some gray solid background colors, which definitely revealed the jail bars that were showing up on the original Famicom. It looks good. There's definitely jail bars. Uh-oh, it's kind of blowing out a little bit as well. That's got to be the capacitor I added. I'm going to take that off and just see what that does. All right, cap is removed, wire is reinstalled. This looks like the problem for the audio jack. I didn't even see that before. What is this doing here? That was like a blob of low melt solder that was stuck on there. Okay, let's go to Goonies, see if we have working audio on that jack. And will this look screwed up? No, that looks fine. There's definitely some visible bars, looks like. Please wait for the demo, by the way. Please wait. There seems to be subtle ripple in the video, just lines, and I don't remember seeing that on my other NESs, but maybe it is there actually. Let's see if this works. Well, as you saw, the audio is working well, the video is working well, it looks really clear, and everything is working fine. Seems that all the problems I ran into were entirely my doing. So if you're doing one of these yourself, check the crystal oscillator. If they send you an extra one, check to see if it's the right frequency, 21 point something for NTSC, 26 point something for PAL. So I'm just gonna spend a moment to properly and fully install this into the console, and that includes drilling out a couple holes on the back for those RCA jacks. Well, putting this back together, I've run into a small issue. It's not a deal breaker, it's just something I have to deal with. So the original Famicom motherboard ended probably around there, and these 4 standoffs were for the RF modulator, that board that connected up. So the standoffs designed to hold the main motherboard, this one and the ones next to the cartridge slot, are actually a little bit lower, or it holds it a little closer to the top. Well, the issue is if I line this up with the standoffs, you can see that those 2 holes are lined up, so are these and the ones down the bottom. But because of that height difference, you'll notice the whole motherboard is at a slant, with this back end towards the back of the machine being held a little more to the right. So if I attach the fasteners around the cartridge connector, which they definitely need to be on there, well, everything's going to be a little bit out of whack. So I think what I'm going to have to do is I'm going to need to remove a couple millimeters of these standoffs using something like the Dremel here with a cutting bit, so the motherboard won't contact those standoffs, and I can just attach it with the 4 normal screws that the original board was held in with, and well, that should fix the problem. Okay, a little bit of trimming later, I think maybe we're in good shape. Let's just give this a quick test fit. Yep, that did the trick. I'm holding the cartridge slot down onto the standoffs, and this part of the board is free floating, which is totally fine. Now, of course, my next problem is this little backboard. It does line up with the little plastic standoffs without issue, but as you can clearly see, the RCA jacks are not going to work properly. So I'm just going to get a marker and draw some semicircles just to match this one here, and we'll have to do a little bit of trimming to, well, make this all clear. It's not perfect, but I think that's going to be good enough for getting those RCA jacks in. And I just need to now reattach this wire. Came off the power switch. One thing about the original Famicom is it's kind of built like a toy. It's just cheap plastic feeling, so working on it, it's kind of annoying. Right, so everything is screwed back together, and I guess I was wrong about these being at a different height. They certainly look like they're at exactly the same height, so I didn't need to shave those off. But beyond that, there's something wrong. The eject mechanism is kind of jammed. Well, and it looks like the problem, that's the eject mechanism. It looks like it's hitting the PPU and the CPU. So those being in sockets means there is just not enough clearance for this to operate. In fact, our clearance problem is this piece of metal. As you can see, it's just running across the PPU and the CPU. How many more issues am I going to run into with this thing, really? And you know what? It seems like this whole thing is a little bit overbuilt, and I am just going to remove it. There's nothing wrong with just grabbing the cartridge and lifting it out of the cartridge connector yourself. That's sort of an unnecessary thing. So, yep, it's going to be retired. And you know what's funny? When I was trying to put this in before and it felt like it was bending, which is what made me think those 2 standoffs were at the wrong height, I think it was because that mechanism was pushing up on the chips and that was bending the whole PCB, which made me think that those 2 standoffs were at a different height. But the reality was that was not the case, and the entire problem was simply the mechanism. Okay, the motherboard has all the fasteners in, so this of course doesn't do anything anymore. Reset button pushes properly, power switch is working. This is our 15-pin expansion connector, so that looks like it's in the exact right spot. The PCB looks good, doesn't look like it's bent. If I hadn't have ground away those fasteners, I could have screwed the motherboard in there. I don't think it really matters since most of the stress is going to be on the cartridge connector, and of course it has 2 fasteners. And luckily for this small PCB at the back, it used to have 4 fasteners since it was larger, but it has little pins here and here that hold it in place, so it's nice and solid as well. As for the bottom cover, just a little bit of trimming is necessary. Let me do that right now. Right, we are ready for a little bit of testing. I just want to make sure this thing still actually works after I've done a bunch of handling of the bare board. It'd be just my luck that I broke the thing handling it. Okay, bench power supply's on, video's hooked up. All right. Still appears to be working properly. Excellent. I switched over to the multi-cart so I can test the inputs. Just want to make sure that the second controller is working. So everything's working on the first controller. Second controller looks good. And talking into the microphone, yep, that's what it's supposed to do. D2 is supposed to flash. Good, everything is working properly. Reset works as well. Here we are in 240p test suite, and there are definitely some jail bars visible on this console still, and I'm pretty sure those would not be visible on a North American NES. I think the routing of the video signal is a little bit better on the North American one, even versus this redesigned console, and that results in less jail bars or ripple or whatever you want to call that slight rippling you see there. Now, one thing I'm noticing is now that this thing's all back together and the second controller is connected, I do hear a little bit of noise interference that sounds like it's coming from the video. It seems to be highly dependent on what's on screen, and I have a feeling it has to do with the microphone input on the second controller. And the testing I was doing earlier in the video, I didn't have this controller plugged in, so I have a feeling it's something to do with that that's picking up the noise, and there's pretty much nothing we can do about that. Let's give the Castlevania 3 demo a try. This has expansion audio. All right, so the expansion audio, the volume level doesn't sound quite right. Now, the thing is, this multi-cart is emulating the expansion audio, and the volume levels are controlled by some resistors on the main board that are mixing the audio together. I'm used to the way the expansion audio with this cartridge sounds on my Famicom, and I bet you was using different resistors for mixing the audio than this is. And to be honest, on my regular NES, I also added a resistor onto the underside of the board, simply so EverDrive type cartridges would also give me expansion audio, and this particular system also sounds a bit different. But I will say that when I was using this cartridge on the original motherboard that was in this, the volumes also sounded quite different than it does while on my NES and on my Famicom. Now there's an audio mix volume setting in the cartridge and it was set to high. Let's try low and see if that's any different. So with audio mixing set to low, that sounds much better, at least more how I think it should sound. Right, so this game sounds absolutely perfect as well. Seems to be working just fine. And I gotta say, the RetroTink capture of composite video on the NES really doesn't look super good. There is a sharpness control here, and it's set to the bare minimum, and still looks very, very dot crawly. Now I know for a fact if I plug this into a CRT, it's gonna look a lot better than it does here. I'm just gonna go upstairs to give this thing a try on my 1702 monitor, just to make sure everything is working as well as possible. So after an hour of playing with this upstairs, I can report that, well, everything seems to be working perfectly. I had no issues, no crashes, no glitches at all. But not all is perfect. I was playing with these other two consoles and just comparing the video output between this new Famicom motherboard and the AV Famicom and my Famicom. And of course, the video output on this is actually the best quality, and that's because the RGB to HDMI that's built into the motherboard on this actually recreates the composite video output. So it's not using the composite output from the PPU, it's actually a composite video signal created from mixing the RGB signal on the output of the FPGA. And that means that this has the least amount of dot crawl and pretty much the best quality video output versus these two. But when it comes to the original video output from the PPU, the issue with the new motherboard on here is that the voltage divider that's on the little transistor buffer that amplifies the video signal creates too hot of a video signal. It's too bright versus the way it should be compared to this console, or this console to be honest, which makes it look not so great on a CRT. It seemed the RetroTink was kind of compensating for that using the auto gain stuff that it has, but the reality is on a CRT that doesn't happen, and it just makes the whole image super bright and the colors get a bit washed out because the chroma signal is now lower than the luma signal, the brightness that's in the composite video. I have a strategy for fixing this, so I'm hooked up to the AV Famicom and we are currently displaying just a full white screen. And the oscilloscope is hooked up to the video output. We can see that the voltage peak to peak, including the sync tip here, is 820 or 810 millivolts. Now we're on the Famicom with the new motherboard in it, and I'm displaying the same all-white screen, and you can see how much hotter the video signal is. 1.2 volts peak to peak, but actually a little bit of it's being cropped off the bottom. So let's just move this up. I think this thing measures basically what is on screen. So we keep moving this up, there we go, 1.4 volts peak to peak. So a tactic for fixing this is adding an inline resistor of the appropriate value. Now I could just alter that little voltage divider that's on the main AV section of the board, but I don't really feel like doing that because we already have a wire that goes between the external board and the main board. I could just install the appropriate inline resistor. So these clip leads contain the video signal, and you'll notice this is at 1.5 volts. If I connect this together, that's going to connect the termination of the RetroTink back to, well, the video signal, which is why I brought this down. There's a 75 ohm resistor to ground on the, well, CRT side or RetroTink side. And what I can do is just clip onto various resistors here to figure out what the appropriate value is to bring this down to that 810 or 820 millivolts. All right, so this combination of resistors gives us 840 millivolts. I'm gonna say that that's pretty much close enough. Time to open this thing up once again and remove that wire that goes to that little back board, and I'll install these two resistors in line. Right, it's a little janky, but there it is. Took the wire out, put the resistor in place, a little heat shrink on there, and this will be fine. The cover should clear that without any issue. I just tried this on the CRT upstairs and those resistors work perfectly. The video looks so much better now. Let's see what it looks like on here. Looks like we still have some of the jail bars. Now, one thing I noticed about this console is that the sky on Super Mario Bros. 1, overall the entire tint, definitely looks a little bit different than it does on the AV Famicom. And I think that's because the PPU in here is a different revision and it must just produce slightly different colors than the other one. At least the way the RetroTink is set up, the sky is kind of a purpley color. And incidentally, any kind of ripple you can see in the background on the RetroTink is not visible at all on the CRT. So the image on the CRT looks pretty much perfect. In fact, it looks exactly like the AV Famicom other than the tint difference now that I installed those resistors. Let me just demonstrate the difference in the tint on the AV Famicom. Okay, well, you know what? On the RetroTink, it doesn't really look that different. I have to say that on the CRT upstairs, it definitely was more bluish on the AV Famicom and a little bit more purple on this one. If anything, I noticed like a couple little sparkles here and there on the AV Famicom that I didn't notice on the real Famicom. Let's give Super Mario Bros. 3 a try. So take note of the red curtain and the color of the background there, that yellowy color. And then notice the sky color that we have on the AV Famicom. Okay, we're back on the actual Famicom. Does it look different? Red curtain, yellow. A little bit more of a ripple there on the actual Famicom than on the AV Famicom, so it has better routing for the video signal. And there's the color of the sky. Does that look the same or not? Not sure. But at least on the CRT upstairs, from a brightness perspective, both of these are basically the same at this point, and any kind of dot crawl around the edges looks basically identical as well. So it seems like the video quality on this, even though it has slight jail bars, when it's viewed on the RetroTink, on the CRT, they look basically identical. Just for grins, let's check out the Famiclone. All right, Super Mario Brothers has more red of a curtain, but of course this has selectable color palettes, and the yellow is a little bit different as well. But see, if I push this button, we can change to, well, different color palettes. I think I was on CXA, which is a very saturated palette. Notice the dot crawl around the cactus there. They just don't seem quite as bad on this console. I think that's just because the way the video encoder works on this is a little bit more modern. The sky is a little bit more blue, at least with this particular palette. And if we run Super Mario Brothers, at least with this palette, the sky color is kind of similar to how it is on the others, but we can change this. For instance, CXA, nice and saturated, kind of how I like it. Makes the sky a lot more bluish, but some people might find this off-putting just because it doesn't look like they remember that kind of a purpley color sky. Just as a side note, the reason why there are color palettes is because all Nintendos, at least the original ones, were composite video output, and the tint varied slightly from one to another. So when emulation came around, people were creating their own color palettes for the way they remembered their NES looking on certain games at least, and that's what all these different color palettes are. Now this thing has a few different ones loaded into it. It's baked into the firmware itself on the FPGA that takes the PPU information, digitizes it, and converts it to RGB, which is then being converted back to composite video, back to S-video for output through the connector here. The whole adage of NTSC being never the same color twice really applies in this case, because this is old analog electronics from the early 80s, and there seems to be so much variance from PPU to PPU when it comes to the way the colors render. And even between these two machines, it's quite stark, the difference on the CRT upstairs. And I think with that, I'm done working on this Famicom. It seems to be working really well, good video quality, good audio quality, about as good as we can expect considering the limitations of what's going on inside of here. Minimal jail bars on the RetroTink, but not even visible on the CRT, and a little bit of buzz in the audio, which I think is being picked up from the microphone on this second controller. Now, I'm sure people watching are going to be asking the question, should you attempt to do this particular mod and swap out the motherboard on your Famicom? No. I'm going to say absolutely not. Do not do it. If you have one of these original Famicoms and you want to have AV outputs, then just buy that AV module that I saw on AliExpress for $30 or get one elsewhere. I'm sure they're all similarly good. While the new motherboard obviously physically fits in this case, well, sort of, it was just way too much work to move all those components around on this motherboard, you know, to the little backboard, and then from the original motherboard onto this one. The fact that they redesigned the motherboard and moved the chips around and stuff is weird to me, because they did that without turning the chips, say, 90 degrees. They could put the CPU over here, the PPU over there, and put those other logic chips in the middle. That would have allowed this eject mechanism to stay in the case, but it just doesn't actually work in here. That just seems like a really weird design oversight. Not to mention the video output level being too high. Why do that? And then the lack of DC blocking on the video output also just seems really weird. I know the video output on this AV Famicom does have a DC blocking capacitor, as does the video output on this and on the original NES. So that just seems like an oversight on this. And I assume there's going to be some display devices I plug this into that are going to really struggle with the fact that the video output on this has that DC offset. And I looked at the original schematic for the NES, the original NES, and it looks like that DC blocking cap should be installed before the final output driver. And it just seems like it's not on this, like some kind of weird oversight. But I guess the fact that the levels are too high on the output just shows that the people who designed this thing probably don't really know what they're doing, especially when it comes to analog video. Yeah. But even with all that said, I'm still happy I did this because it was a learning experience and a cautionary tale for everyone watching. And whatever problems plagued this thing before, there was obviously something wrong at some point. Well, I think those are going to be fixed. And I'm really glad to have reused the PPU and the CPU that was in the original Famicom. So the heart of this machine is still the original 1983 or 84 console when this thing was made in Japan back in the day. Now, when it comes to what Nintendo I'm going to be using in my normal day-to-day activity, it's still going to be the Famiclone. This thing is awesome, and I absolutely love this thing, and I use this all the time. I love the more vibrant colors that this thing has and the better quality video. Not to mention, I usually have this hooked up to a 1702 upstairs with the Luma Chroma, the S-Video mode, and it just gets rid of all the dock crawl, which is honestly a win-win when playing NES games. But I do like to know that I have an original Famicom that I can use on demand, and an AV Famicom, and a bunch of original NESs. It's down here somewhere in the basement. I have a bunch more of those. I'm just swimming in Nintendos, which is never a problem in my book because I hope to have a working NES console pretty much for the rest of my life and one running all the original chips. Luckily, these things are quite reliable. In case anyone's wondering, I will be keeping the original motherboard and the RF board along with the eject mechanism in this bag here, and it goes into my NES bag of parts just in case I ever want to try to revert this thing back to its original condition. I can do that. And I guess that's going to be that. So if you have any questions about this upgrade that I did, comment down below. I hope you enjoyed this video and watching me struggle. I have to say I cut out a lot of the trouble that I had moving those parts around just with that whole voiceover section in the middle. I'm glad I did that though, because this video would have been way too long and way too boring to watch me struggle desoldering stuff for hours or whatever it took me to actually do that. Thumbs up if you liked it, subscribe if you haven't already, huge thanks to my supporters, names go up the side of the screen, all the usual YouTube junk, and that's gonna be that. So stay healthy, stay safe, I'll see you next time. Bye.